My name is Serge Pankar. I'm moderating the event that is getting started with TensorFlow Datasets, which is being given by Godfrey Nolan. Godfrey Nolan is the founder and president of RIIS LLC, a mobile development firm in the Detroit metro area. He is also author of Agile Swift, Agile Android, Bulletproof Android, and Android best practices, decompiling Java, and decompiling Android. We're very happy, Nolan, for us to join you. And Nolan, you can now start your presentation, please.
All right. My name is Godfrey Nolan. What I'm going to talk about today is TensorFlow Datasets. I work for a company called RIIS, which is based in Troy, Michigan, which is where I am at the moment. And why do I have an interest in TensorFlow? Well, basically, I have an interest in TensorFlow because I have developed a number of apps for drones, and what we're trying to do is use object detection from TensorFlow. So basically what we've done is we've done the hello world, we've done the image classification, we've done the object detection, and then what I'm trying to do is just explain how TensorFlow datasets will make your life easier. TensorFlow datasets are basically almost 250 datasets that people have aggregated together, that Google have aggregated together. They're mostly public data sets. There's a few Google ones in there, but by and large, they're all public university research database data sets that come from around the world. But TFDS allows you to pretty easily add them to your own little app. So I'm basically going to show you how we work through going from hello world to getting introduced to TensorFlow datasets, because the main issue that you have is, well, that I had, so I'm assuming everybody else does, was what do I do after hello world? What do I do after I've done the Lawrence Moroney Coursera courses? What's the next step? And how do I do it relatively cheaply? Because I don't want to have to do my own data sets, because that can be really expensive, which we'll explain to as well. If you do have any questions, I will be looking at the chat session, so feel free to ask as I go along. Okay. So, founder and president of RIIS LLC. I've written 6 books, mostly on Android development and Android security. I'm an adjunct professor. I teach at Saginaw Valley State University in the fall on Android development, and then I teach at the University of Detroit Mercy in the winter term, also on Android development. So what is TensorFlow? So back in the 90s, which was when I was first playing around with AI stuff, if you wanted to do any AI or machine learning, you really had to roll your own backpropagation neural network. From personal experience, I say, it wasn't impossible, but it took a while. So they were usually simple examples. The classic one being this hello world that we have here. So these days, it's much simpler. You can call any number of machine learning models from frameworks such as TensorFlow or PyTorch. So TensorFlow, what it is it's basically a framework that sits on top of other people's research, other people's neural networks. And it allows you to, get the latest and greatest, because they're updated pretty often. Neural network or other type of models, allowing you to easily train your models to have predictions. Predictions in whether it's a number, predictions in whether it's a choice, predictions in whether it's an object or an image. And that's huge. So basically, what it is it allows us to, instead of you having to write your own C++ code back in the day, you can now get started in Python, fire up a Google Colab, and get something going in a really short amount of time. So the following example is a hello world for TensorFlow. So we're trying to get the neural network to match the equation, y equals 3 times x plus 1. So when we ask what y is, so basically what we have here is we're setting up a sequential neural network. We're saying that it's got a unit 1, which is saying that the number of layers that you have is 1. So you can have, in a backpropagation layer, you can have lots of different layers. and the input shape is 1. So we have X and Y, so we pass into this is our model here in SGD, and we're passing in our data. So we have 6 elements and all of type float. So we're passing in for X and we're telling it what Y is. And basically we are over 500 steps, training steps. What we're trying to do is to get the accuracy to a high enough level so that it can predict Y for any number. So when we enter X here is 10, it gives us 31.002 and some change. So pretty close, not exactly, but our prediction is pretty good. So, when I was doing this, it was like, okay, well, I kind of understand what we're doing here. I wish there was more. So I was struggling with what to get to next. And the MNIST was the next one we did. And then slowly but surely we realized at the time there were only about 3 dozen TensorFlow data sets, but there was still enough to get going. And now there's close to, I think it's 225. And you can now add your own if you have stuff, and we'll talk about that later too as well. So I think it's just a really good way to get started. I'm going to be jumping around all over the place, so hopefully this works. So what I want to do is get to this. So this is I have all the resources at the end of the PowerPoint. And what I'll do is I've put it up on SlideShare. I also have I recorded it in YouTube. So if anybody wants to see, what I talked about, they can go back and look at it in the channel video, or you can just have a look at the PowerPoint. And then I'm always available to talk about this. It's always an interesting topic for me. So this is the Codelab, which is not to be confused with Colab. So Codelab is the thing that Google use for little programs to help you get up to speed. This one's done by another Irish guy, Lawrence Moroney. Great guy. New book coming out next week. There's also, he's got a couple of courses from Coursera, which I also put in the resources, which is a great way to start if you want to get into this in a big way. And then we have so basically it's talking about what's ML. It gives you create your first ML program. So we can get across to opening up the Codelab. Sorry, the Colab. See, I'm getting confused too as well. And essentially what you have here is a working notebook. So we have a notebook, so we can, if you're teaching, it's great. You can add little text. And if you're trying to make it run too as well, we can make it run. So what I'm going to do real quick is I'm just going to run all. Actually, I'll run it, but it's going to take a while to do the 500 epochs. So that's probably going to take a while. But just to show you that it works, and we'll return later, and then it'll do a prediction, and we'll probably get the same answer. Okay. There is more information on what it's actually using. So I can never remember what SGD stands for. So it's a stochastic gradient descent. So that's a type of optimizer they're using. And then to figure out what the loss is they're calculating the accuracy of the loss, and the loss they calculated by mean squared error. So what's the mean squared between what the prediction ended up being and what it should be. So you have 2 sets of data. You have your training data and you have your test data. So this is on the training data. So they know the input is, if it's 1, it should be 4. So they're going to figure out what the mean squared error is. And that's what your loss is. Okay, let's go back to the PowerPoint again. So that's a really simple example of just a little TensorFlow model, but it has a lot of the same elements as what you would have in a much more of a production TensorFlow workflow. So it has the load, the train, and the test. So it's loading the data, it's training it. Admittedly, it's training it on a pretty small data set of whatever it was, 6 elements, and then it's testing. So and it's testing, we just do a prediction. So I think I mentioned earlier on that we do a lot of drone work. So this is one of the drone apps that we did. We were very lucky. We entered a Google Dev Fest, and it won an award on the last TensorFlow. Unfortunately, because of the TensorFlow conference, but unfortunately we couldn't go to the conference because of COVID. So hopefully we'll get to go in future and show it off. So this is using object detection. And in object detection, what you have to do is you have to label the images. So we would send somebody out to fly a drone, and they'd take it in 50 feet above the sheep or the cattle, because we did both. And then what you do then is that you would take that video, you chop it into images, and you need about 5,000 or 10,000 images to be able to get a decent accuracy. Somebody has to go and draw boxes around each of the objects that you're trying to detect. So in this case, we're trying to detect sheep. So somebody has to go very laboriously use an image label program to go and put a box around it. We tried it with the interns. I think it drove them crazy. So really what we were trying to do was to make it, see if there were better ways to get there. So then the next thing that we did was we said, okay, well, we'll outsource it. So we outsourced it to Fiverr.com. There's a couple of websites out there, like The Hive is one. And we also try to use Amazon Mechanical Turk to find people who actually wanted to do this for a living. And it worked out somewhere between 50 cents and $1 for every image, depending how many objects, how many sheep or how many cattle were on it. So if we're looking for 5,000 to 10,000 images, that could get really expensive really quickly. So as we were going through this and trying to learn things, because a lot of what we're doing is we're doing this not for, in this case, any real world application. We know they're going to come in the future, but we're just trying to get a step above what we were doing in the previous drone app, a step above what we were doing in the previous mobile app. So the solution to that is basically the TensorFlow datasets, because the TensorFlow datasets solve my labeling problem by providing a very simple to use loading mechanism for the 200 plus public research datasets. Not to say that there are, over 200 object classifications, object detection databases out there. There's much less than that, but there's certainly enough for me to work on, and I'll show you what that looks like in a second. So, assuming your use case is covered by one of these data sets, that's great. So, but not only that, you can also pre-train it with the data set that's out there and use a smaller data set to retrain it afterwards. So there's a lot of data out there to be able to help you to get a jump start on what you're trying to do for whatever TensorFlow that you're trying to create. So TensorFlow, if you go to the GitHub site, it says that there's 4 core values: simplicity, performance, reproducibility, and customizability. For me, it's the simplicity. So every time that you go and look at one of these apps or one of these data sets, everybody does it a different way. So if you go and look at the MNIST, you have to download within your Jupyter Notebook on Colab. You have to download it, unzip it, and it may not be tarred. It may be just zipped. So you might have to write a script, and then it might put the classifications in a different way that you don't want to have it. So what TensorFlow Datasets does is it gets rid of all that. So basically everything is, you get the information, the metadata to tell you exactly what's in the data set, how big it is, how many classifications it has, what the training versus test makeup is. And you do a tfds load command, and you can get the data ready to use almost immediately. So for me, it's the simplicity that is the winner here, and also the reproducibility. So in our case, what we're trying to do is we're trying to make sure that our Jupyter Notebook runs over and over again, that we don't really have any issues when we rerun it 3 months, 6 months later when we're trying to demo it to somebody, or if we put something up on GitHub, that we know that it's going to run the same, and we don't have to go back and fix it because somebody has updated their whatever data set that we're using. They've changed the format, and then we have to rejig what we did with our Python code to make sure that it works again. We don't have to do that with TensorFlow datasets. Basically, it's the same command regardless of whatever data set that you're using. There's different parameters for sure, but it's always going to be the same. And if you come back in 6 months, the format wouldn't have changed. Another thing that's important too as well is there are some caching going on. I'm not exactly sure whether the data is in the Google Cloud somewhere, or whether it's still sitting on the original database that it was the university had put the database. But a couple of times in the past, we've gone out to the public research, the university database link, and it's a university. So from time to time, the URL, the website will go down, and we haven't been able to access the database. But if we go to TFDS, we find that we're able to access it. So the whole reproducibility thing is huge for me. Somebody's asked what image capture tools exist. The image label is the one, the label image, excuse me. If you search for that on GitHub, or I can send you a link after this talk's done. I can share where that is. It's a pretty time-intensive tool. It's good for starting out, for playing around with it. Essentially, what you do is you tell it what objects you're looking for, you put the boxes around it, and then save it, and it saves the XY coordinates, and then you use that with TensorFlow to be able to create the TF record, which is what you're using for testing. It's kind of it's a definite skill set and something that's going to be needed in the future. But it's a certain type of detail person who wants to do that over and over again. So that's it is not something that I would. We tried to get lots of people to do it here. You got to find people who want to do this as a job. Otherwise, the quality is going to be terrible. They're just going to miss things, and then the efficiency and the accuracy that you get is, is determined by the data that you get inside. So your labeling is a huge thing. So if you already have a labeled data set, then so much the better. Okay, so what type of TensorFlow data sets do we have here? So certainly if you're getting started, there's something for everyone. So I'm mostly interested in image classification for mobile apps and object detection for the drones. So we just did an app the other day. A lot of the times it's the interns who do this. So what we're trying to do is we'll come up with an idea every quarter for 3 things that we want to do. And on the AI side, on the drone side, usually it's the interns who get to play with this to figure out how to get it to work on whatever the new drone is. And I'll show you some of the applications that they wrote during the summer, which we're giving away the code and the notebooks to as well. Somebody has asked, how long does it take to train a data set to ensure accuracy? It's a bit of a black art to figure out how to get a 100% accurate. You won't get 100% accuracy, let's put it that way. Even in our simple hello world, we didn't have 100% accuracy. We're looking for 90-95% accuracy on our object detection. We are nowhere near that. We're more in the 80% range. We used GCP to do that, Google Cloud Platform. So there's another expense there as well. We have done it now on Colabs, and it will run overnight in Colab and give us an accuracy that we're looking for. So with our test database, it gives us pretty good accuracy. Out in the field, literally, that's my dad joke for the day. When it's looking at trying to find the cattle or cows, our accuracy is probably about 80%. So we need to get that up. But that takes about a day to do that on Colab, and that's with the GPU that we use on Colab. And I'm going to explain that there are how to use Colab later on to get it as most efficient as possible. So GCP is really for production level TensorFlow apps that you're trying to do. But the problem with GCP is there is a pretty steep learning curve. Colab, you fire up a web browser, you're up and running in 5 minutes. Whereas if you're trying to do it with GCP, it can take you 2 or 3 days to get it configured properly. It's probably got better now, but certainly when we were doing it at the start, it was quite difficult. Okay, so as like I said, the format's always the same. So it makes it easy to load into a TensorFlow notebook rather than have to figure out and download and import each time. I'm going to go and have a look at some of the data sets first. Okay, so let's get out of this. Let me go to... Okay, here's all our data sets. We go to catalog. You can see all the different ones in here. let's go to image classification and talk about, I guess, MNIST, which is probably a good one to start with. Horses or humans, that's a Lawrence Moroney one, so that's actually Google provided, and there are a few of those, but there's lots in here that are nothing to do with anything else. So in here, we can see that the home page for MNIST is this URL, so hopefully that'll come up relatively quickly. You know what? Yeah, there it is. So the MNIST database of handwritten digits. So this is the master database of all the stuff that goes on. So as they change images, if they do it with the MNIST database, if it gets updated at any stage or any of the data sets, there's always like an end result URL, the homepage that you want to go to figure out what's going on. So in here, we have some metadata, which tells you what the download site is. So it's, it's pretty small. The shape of the images, so 28 by 28. And then we have a little bit more information on where it came from, who's responsible for it. And then we have some examples. So you can see here that it's handwritten digits. So it's what the Postal Service, USPS, uses to train some of its machines. And I'm sure lots of the postal services all over the world use this. And this is a smaller version of the NIST database, which was the original database. Okay, the one that we were using for object detection, that is the COCO database. And that is the Common Objects in Context database. So it's actually a Microsoft database, Microsoft sponsored anyway. And it's got a bunch of different, let's see if we can find the images. So it's basically a ton of different images, which they put in different classifications. So whether it's human, whether it's a building, whether it's a toilet, whether it's food, these kind of things, whether it's a horse. So what it does is it gives you a baseline to be able to test a lot of the different things that you may want to see, whether you're using just a mobile app. Yeah, I should say in what we do is you don't have to do this in a mobile app, but because we're a mobile company, mobile dev company, what we do is we basically turn everything into TF Lite. So that's TensorFlow Lite, which is a smaller cut down version of what the TensorFlow model is, so that we can put it in the assets folder in our Android app, or we can put it on iPhone and then use that to actually be the camera for what we're trying to detect. The other one I wanted to talk about as well was the Yelp, because if we have time, we're going to run through that. Okay. So Yelp is the restaurant guide. So there's 560,000 of these reviews, and then basically they have a 1, 2, 3, 4, 5 to say whether it's a positive review or a negative review. So it's a good thing to start testing. It's a great example to see how we're going to load the code. So I'm not going to run that quite yet, because we have to talk a little bit about how we actually load the TensorFlow dataset. Let's get back to this real quick. So here's how we load it. So we say our data set is equal to tfds.load MNIST, which is the one I showed you. Split, we're going to take out the training in this case. And shuffle files equals true. So just like a pack of cards, we're going to shuffle the deck. There's lots of other things you can do with split. So you can take out the test database. You can take out a percentage of the training database. You can define where you want the data directory. There's a default one, but you can define where if you want to change that. The Colab is a Unix box, and I'll show in a few seconds how it all fits together. And then with info equals true. So if we want to take the metadata down true as well. And sometimes you just want to take down the info and you don't want to take the actual data set as well. So you can set download equal to false. So really straightforward. Gets a little bit more complicated if we're trying to pull in the Yelp. But basically what we're doing is saying there's 3 parameters, which is our train data, validation, and test data. So that's our data set. And what we're doing is loading the Yelp polarity reviews. As that's one of the 224 data sets. We're going to split it we're going to take a 60% for a training, 60% for a validation. And then we're going to use our test for our test data. Not too sure what our supervised equals true is off the top of my head. Okay. So there's, in the two major classifications that I'm interested in are image classification. So in that we have birds, so we have a way of seeing what different types of birds are, using the camera on your phone to be able to say what type of bird is. As that knowledge is getting less and less in different generations, it's much harder for people to be able to say, oh, it's this bird or that bird. So you would use Caltech birds, point your camera at the bird on the phone, and it would tell you what the bird was. Cats versus dogs, cars. So this is the one that we have here, which is, all the different types of cars, Volvo, Suzuki. If you want to be able to create an app that wants to show what different types of cars are. Horses or humans, that's the Lawrence Moroney one I talked about. Stanford dogs, we actually use that in one of the apps that we have, which is up on the RIIS Play Store for Google Play. And somebody asked, what is the best site to get TensorFlow datasets? That's the tensorflow.org/datasets. That's the place to go. And then it will tell you all of the different things that are out there, all the unique datasets. So you can see all of these are unique. So you would do tfds.load Caltech birds in commas, and then cats versus dogs, and that's where you get them. Not to say that you won't ever use other datasets, because you only have 224 to choose from. And if you do a Google search, there are so many different datasets out there now that I won't say that you should never create your own, but certainly if you're learning, it would make much more sense to just use one of the datasets that are out there. Flowers is flowers, and rock, paper, scissors. That's an assignment that we often give the students in my class, which is to write an Android app to detect rock, paper, scissors. And then you basically there's a random number generator, which means that you're going to try it out against the computer. And then the object detection databases, COCO is the one, the Common Object in Context. We also have Kitty, which is for autonomous driving. VOC is lots of different objects for people, cars. I think that's the examples I'm pulling here on the right-hand side. Waymo, not surprising that that's another automated driving database. So you're talking about stop signs, you're talking about traffic lights, pedestrian crossings, and then wider face is for facial expressions. So you can see if somebody's smiling, if somebody's happy, if somebody's sad. So you can see how that would be interesting for either a retail application, or if somebody is on the autism spectrum and wants to use it for figuring out what the facial expression is. So you can see lots of different interesting apps that you could do based on these data sets. So each of the data set does include some, but not necessarily all of the following metadata. So there'll be a description where it comes from. There'll be a home page, the download size. You'll know how long it's going to take you, if it's going to be gigs and gigs of data, or if it's going to be something small like the MNIST. And then example images, and then some code, hopefully, to show you how you should be calling it, what the shape of the images are, those sort of things. It's not always there, but it's a good place to start, to be able to start downloading the data. Okay, so I want to run, this is the Yelp example. So I want to run through this and hopefully have enough time to get an answer. So the Yelp polarity, we talked about that. Here's the actual review. So the runtime is disconnected. So this happens all the time because I ran it earlier. So let's reconnect it. Okay, so now we are connecting. You can see up here that it's saying initializing. So I know that I have this RAM and I know that I have this disk. I am going to start running it because it takes a while, and then I'll explain how it all fits together. So first of all, I want to make sure that my runtime type is what it needs to be. I'm going to go for GPU, but you can choose TPU as well if you're running the Colab Pro. If you're not running, which is $10 a month, if you're not running the Colab Pro, you can ask for a GPU, but it's not guaranteed that you get it, but you typically do with the Colab Pro. And then high RAM is just something that we're going to want to go for. So I'm going to say runtime run all, let it get going before I explain things. Okay, so it's gone through the first and second already. Find all the available data sets. So it's basically built a list of all the data sets. So now it's pulling in the data set. So it's already pulled it in. So It's saying that it wants to take just 60% for its training data and its validation data, and it wants the whole test database. It's now going through the downloading all of the different examples. Excuse me. And then while I'm here, what I want to show you is you start off here, but if you click here, you can actually get access to the file service itself. And then you can see that it is, here we have all the files. So I know from the previous time that I ran this, that it is in root, TensorFlow Datasets, Yelp polarity reviews. It hasn't downloaded everything yet, but it's going to start appearing there in a second. And then when we run that, what we want to do is we want to basically it's just going to make sure it's got everything correct. It's going to use it's going to change the text into vectors because it's easier for it to train on vectors. It's going to set up a sequential list. It's going to have two different layers. So basically, it's going to have a 16-layer back propagation and then an extra layer 2 as well. So this is much more complicated than we saw before. And then it is going to have only 5 epochs. So it's not 500 epochs. It would probably take us an awful long time to run it if it was 500 epochs. And then it's just we're going to do some simple testing based on the test data to see whether it was successful or not. So it looks like now we have, well, it's not incomplete yet. So I'm going to come back to that in a second. Yep, it's still going. So let's come back to that in a second. I'll skip to the next slide while this is running, and hopefully it'll be done by a quarter to. Okay, so it's simpler than the Google Cloud platform, Colab. It's just way simpler. We can basically point an intern, point somebody who never used this before, and they can be up and running, within 5 or 10 minutes. The cool thing is that they can get GPU or TPU, TPU being TensorFlow processing unit for $10 a month with the Colab Pro. It will kick you off if you're using it too much. It has a habit of doing that by disconnecting, but there's lots of things that you can do before it gets you to kick off, before you kick it off. So it's the perfect system for trying out what you're trying to, whatever idea that you have. It's a great way of, if you're not that worried about the accuracy yet, you can figure out if you're going in the right direction, if you've got the right number of layers, if you've got the right data set to be using for whatever you're trying to train. And then if you were going to go to the production version, you would move to Google Cloud Platform. Having said that, we didn't do that for any of the apps that I'm going to show you a bit. And then where does everything live? Well, we talked about where the data lives. It's, you have access, you can upload and download files. So for example, if you, one of the Coursera courses, what it talks about is using the TF Flowers data set, and then you can add your own images as well. So it shows you how to go into the Colab and upload the files. So you can add your own and use that to retrain the database on what it's already been trained on. So we have here are the 4 different apps that we worked on, our interns worked on over the summer. So we have Doggy in the Window, which uses the Stanford Dogs data set. We have Identiplant, which doesn't actually use the TFDS data set. It uses a Plant Village data set because there are times when you're going to have to go outside the TensorFlow data sets. There's the Food Classifier, which uses the Food 101. And then there's the Flower Classifier, which uses the Oxford Flower database, which is also in the data set. So let me go back here. All right, so this is now finished. And it looks like we're off testing. So we're already at 3 out of the 5 epochs. I just wanted to show you where it lives so you can see. So we have our labels. So that would be the 1, 2, 3, 4, 5. And then we have our data here, which is in a TF record form. But you can download that too as well, or you can add more yourself. So you have access to everything on the Colab. and you can install whatever packages that you want to as well. So it's pretty neat tool. Certainly gets you a lot further than a lot quicker than not a lot further than GCP, a hell of a lot quicker than GCP. Okay, what was I going to show you? So we have these apps. Okay, so the first one is Doggy in the window. So just show you real quick what that looks like. So what we did is took the database, took some standard images from the database. It gives you what the percentage accuracy is that it thinks what it is, what your dog is going to be. You can also upload pictures of your own dog. So if you want to take a picture of your dog, or if you see a dog and you're not sure what it is, and it says this one is the golden retriever. Here's a list of all the different dogs that are in the Stanford Dogs dataset. So there's a ton in there that you can see everything that's going on. And then we wanted to make sure that we're not taking credit for this, so we also have a link back to the original dataset page, and then also we put the code on GitHub. So I'm hoping this will be useful to people. So what we did was we have, if you go to this URL, so for we have the code in Kotlin, so it's using the Stanford Dog database. Plus, we also have the Jupyter file, so you can then upload that into Colab and play with that to see what that's like. And then for each of the different, and it also shows you how to use the Colab to export a TensorFlow-like file. Sometimes that can be problematic. So if I show you this, I won't really need to show you any more videos because it's pretty obvious what we're doing here. So basically what we have is, in this case, it also includes whether it's got any issues, so such as if it's got any diseases. So that's not us. That's just taken from the database. In this case, this was the Plant Village data set that we used to as well. So it's saying it's got light blight. Okay. Similarly, we have the food classifier and the flower classifier. If you want to go play with them, all the code is up on public repos on the RIIS GitHub site. Cattle counter. They're the ones that we did a few years back now. We have one for DJI drones and one for Parrot drones. Still need to push them out onto iOS, but we don't have them yet. Okay. Like I said, the problem with other data sets is we need a custom script to load them. Many of these, like for example, the Kaga ones are already moving to TF data sets. But there are still lots out there that you may definitely want to play around with, so that you won't be on TFDS. So you'll just have to write your own code to do that. But once you've done it with TFDS, the concept kind of is much simpler for you to be able to explore with other data sets. So I would recommend starting there first. So future plans. So what are we trying to do? We're trying to do more apps early in the new year. We're also looking for Canadian interns this time around. So if anybody knows anybody who might be interested, please send me an email. I have my email at the end of it. So so we're, if you're, I don't mind whether it's University of Windsor, but anywhere else, if anybody's interested, we're very hot and trying to get some interns to play around with this and create similar apps than I showed you before. So we're going to do one with snakes. So we have a snake data set to say if a snake is poisonous or not. Mushrooms, there's a Danish app that detects if a mushroom is going to make you sick or not. The only issue with the mushroom database is the app uses crowdsourcing to get lots of people to upload their own mushrooms, whether they're going to make you ill or kill you. Unfortunately, the data, there's no quality associated with that. So there's a lot of pictures that aren't mushrooms. We're looking for a spiders database to see if if the spider is a brown recluse or if it's a black widow, that kind of thing. So as you can see, I have a major problem with poisonous things. So, but that's really, we think that's a great way to, get some interest and maybe get some marketing out of this. And maybe when I showed this to somebody else, they said maybe you should add quicksand to the list. But if anybody's got any other ideas, we're more than happy to try. Also, something else that's happened recently is that TensorFlow 2 has been out for a few years, But TensorFlow 2 object detection API has not. That's fairly recently been upgraded. So we want to upgrade our 2 cattle and sheep counting apps to use TensorFlow 2 and hopefully get a better accuracy out of that too as well. And then the cattle and sheep TFDS. What we want to do is we have 2 large-ish data sets for labeled cattle and labeled sheep, and we want to see if we can figure out how to get that into TFDS so we can be number 225 or whatever it is at that time. Okay, lots of resources here. So the data sets, that's the URL, the Hello World, Codelab, not to be confused with Colab. The 2 Coursera courses, which are a must if you're trying to get into this. The URL to our Google Play so you can play with the 4 apps that I talked about. The data sets are also up on GitHub, TensorFlow GitHub. There's lots of more information there too as well. And it's worth, once you get past the website for the dataset catalog, look at that too as well. If you want to look at some of the very first collabs to see how to use datasets, there's an example there. And then the last one is the Yelp example that I took. I found that on GitHub, and I just wanted to give the guy a link. All right, got a couple of minutes left. I'm going to answer a couple of questions. Somebody asked, suppose you had a model you trained for, then your requirement for that change, would you retrain the model or possibly change the model, then continue, or do you have to start over? No, you don't have to start over. If it's changed slightly, basically you could use, you can retrain the model. So if we want to do cattle, sheep, or horses, we did cattle, sheep completely from scratch, but there's no reason that we need to do that. We can take a much smaller number of horses now and use that to retrain our database. So if your requirements change, you don't have to go back to square one. It was just our lack of knowledge at the time that was why we went back to square one. So you don't have to if you look up some of the examples of people using the base object detection models or image classification models and then retraining them. And then somebody else, dangerous poisonous identification is a great practical use for these AI apps. Yeah, we're also looking at some insects as well. There's a couple of insects that we want to make sure that we have, we can use that to help with some of the diseases that are coming from Central America up into Texas now. So that's coming in the future too as well. Okay, thanks very much, guys. It's a weird world that we live in. Appreciate you putting up with the online version, and hopefully we can meet again sometime in the future. Thank you.